Right. Good evening, everybody. Till the last class, I have taught about working of thermal power plant. Right. I spoke on the basics of conventional, and we came to unit 2. We have started with unit 2. Okay. I have explained about what is a thermal power plant. Okay, what are conventional, what are non-conventional power plants we have discussed. Merits of conventional, merits of non-conventional power plants also I have explained in detail. After dealing all with all the basics of power plants, we went about discussing, or we went about learning about thermal power plant in detail. Right. First, in the last class, we were dealing with components of thermal power plant, how how a thermal power plant should be chosen. What are the deciding factors while planning a thermal power plant? What are the factors which affect it? Okay, what all should be needed? What are the minimum requirements, and what all should be there? What all should be controlled, and what all should be measured in a proper manner? Okay. Next, how the area should be chosen. Okay, what all facilities it should have. Okay, what are the disadvantages of this thermal power station? Because using thermal by using thermal power station, what harmful effects we will overcome, or we will come to see. Okay, what harmful effects are there, how to reduce also I have told. Right. In today's class, we will deal about thermal power plant. The main working parts of thermal power plant we'll discuss in detail. Okay. First is the subtopic of today is line diagram. Line diagram means in a single representation, or in in a small in a block diagram format. Everything will be explained. Okay. Even each and every part of the thermal power plant will be explained. Right. Coming to the In the previous lesson, we have learned about principle of working of thermal power station, factors affecting the selection of site for thermal power station. Right. On completion of today's topic, we will come to know about the line diagram of thermal power station, various components of thermal power station, working of thermal power station, function of each component. Okay, what all the components are involved in a thermal power station. Okay, and by joining all these components, how thermal power plant works. Next is function of each component of thermal power station also I'll discuss in today's class. Right, this is the heart of your power plant. Okay, right, this is the line diagram, or this is the single diagram which is showing your thermal power plant in detail. Each and every component and each and every part of your thermal power plant is covered, and it will and I will explain. Okay, I'll try maximum I'll try to explain each and every point of this line diagram, so that by learning or by understanding this diagram thoroughly, we can get an excellent idea about thermal power station. Right. Coming to the starting, or coming from the left side of the line diagram. Okay, first is I'll tell you what are the main parts, and I'll tell you what are the sub parts, or for helping the main parts, what all are the sub parts we'll discuss later. First, I'll tell you what are the main parts which are involved. The first main part which is involved is a boiler. Okay, in a thermal power plant you require a boiler. Second is you require a superheater. Okay, third is you require a turbine, and fourth is you require an alternator. Okay, right. Along with this boiler, superheater, economizer also is the main part, air preheater, turbine, alternator. Okay, almost there are six main parts which are involved. There are six main parts which I have told: boiler, air preheater, sorry, superheater, economizer, air preheater, turbine, alternator. Right, coming to the starting part of the power plant, which is boiler. Right, as the name itself specifies, boiler. Actually, this is a thermal power plant. What is thermal? Or thermal energy, or you can also call it as heat energy. Okay, as this is heat energy, boiler converts uh, mm, boiler boils. Okay, boiler, I mean, by using a boiler, you'll try to convert, I mean, what is the thermal energy means? It is heat energy or steam energy. Okay, how you are getting steam? In order to obtain steam, you require a boiler. Okay, right. What does boiler does is, boiler, I mean, boils the water, means you need to have water in the thermal power plant. Okay, you need to boil the water. For boiling the water, or in order to convert the water into steam, or in order to get heat energy or thermal energy which you are obtaining from water, you are using a component which is called as boiler. Right, so boiler is the first important component which you require in order to convert water into steam. Right, after that, whatever the boiler does after converting the water into steam, or after boiling the water above 100 degrees centigrade, that steam energy, okay, is not sufficient enough. So we need to add some more components in order to increase the steam energy, or in order to increase the thermal energy, we need to add some more heat energy. So we are using a superheater. Right, this superheater, what it does is, it again increases the temperature of the steam. After boiler, whatever the steam energy which will be given to superheater, it will increase the temperature of the superheater. Okay, right. Next, economizer and air preheater. Economizer and air preheater also are the additional components which are attached to boiler. I mean, they both of them help. I mean, help a boiler in working efficiently. Okay, I'll explain in detail what air preheater and economizer does. They are like they are additional components, or they are the parts which are added to the boiler in order to increase the efficiency of the boiler. Right, after superheater, right, what superheater does is, it increases the temperature of the steam which is coming from the boiler. Right, this superheater is connected to main valve. Okay, after connecting this superheater to main valve, this main valve is connected to turbine. Right, after connecting this main valve to turbine, right, what this turbine does is, whenever the steam energy is given to turbine, right, this turbine is the device which will convert which will convert steam energy into mechanic, or heat energy into mechanical energy. Means the turbine has blades in different directions. There are different there are different arrangements, or there are different designs of a turbine. Okay, based on the arrangement of blades, okay, the turbines work. Okay, after the I mean, from the main valve, the steam is given to the turbine. Okay, as the steam is passed or it is given to the turbine, the steam will be radiated. This steam will be this steam will be passed to the turbine. Right, as the steam passes to the turbine, what happens is, this turbine, I mean, on incident of the steam energy, this turbine will convert this heat energy into mechanical energy. Right, as mechanical energy means, it will move, I mean, however the way, or however the angle in which the steam is getting focused onto the blades of the turbine, your blades of the turbine start rotating. That is only your steam energy is converted into mechanical energy. Right, this turbine, again, the this mechanical energy, or the mechanical output of the turbine, is connected to the is given to the alternator. Alternator is a device which converts, or alternator is the other name for AC generator. As the definition of AC generator, it converts mechanical energy into electrical energy. Means, for an alternator to operate, we require a mechanical input. So this mechanical input is being provided by the turbine. This turbine will give mechanical input, will give mechanical energy as an input to the alternator, and this alternator converts mechanical energy into electrical energy. Again, right. Again, I will explain what all the parts are present in this diagram in detail. To the right side of the alternator, there is an exciter. Right, why an alternator requires an exciter is, alternator is a device which will convert mechanical energy into electrical energy. Okay, as alternator is converting mechanical energy into electrical energy. Okay, this mechanical energy is given from turbine to the rotor of the alternator. Again, what you need is, for rotor you need some DC excitation. That DC excitation is given by your exciter. As your rotor needs DC excitation, you need an exciter, or your rotor should be given to DC supply, right? If your rotor is normally, if your rotor is given to DC supply without given to turbine, without given to the output of the turbine, what happens is, for the DC supply, whatever the field which is generated, it will be constant. Means E is minus and d phi by dt. I mean, rate of change of flux is not there, so EMF will not get induced in the alternator. In order to get the EMF induced in the alternator, what we do is, we will couple the rotor. First thing, we give DC excitation to the alternator, to the rotor of the alternator. Again, this rotor will be uh, turbine, coupled to the outlet of the, or output of the turbine, right? As it is as it is connected to the output of the turbine, as this turbine will be rotating, this your rotor also will start rotating. Okay, based on the rotations of your rotor only, you will get frequency of the EMF induced in stator of the alternator. As you know, F is equals to Pn by 120, as the number of poles are fixed. By changing the speed of rotation of the by changing the speed of rotation of the turbine, or by changing the speed output of the turbine, you can change the frequency of the alternator. Okay, right. Coming to the remaining parts, coming to the boiler. Okay, nearer to boiler, what all parts are there, I'll explain in detail. Okay, boiler is in this layout diagram, or in this line diagram, sorry. Boiler is shown in circular form, right? For the boiler, left side, whatever the components are there, I will tell. First, on top, I mean, to the left of the boiler, from top I will tell. Right, this thermal power plant will come under the category of non uh, will come under the category of non-renewable power plants. Okay, it is not a renewable power plant, it is non-renewable power plant. As it is a non-renewable power plant, you need to provide some input to this. I mean, input is not free, it is not like it is not like sunlight, it is not like wind. Okay, you need to provide some input. Next, this thermal power station, it is producing heat. Okay, this heat, you are getting heat obtained from water with the help of coal only. So you need to have coal in order to run your thermal power station. Means the primary or the fuel requirement, whatever is there for your thermal power station, it is coal. Okay, this coal, I mean, you need to store coal. I mean, daily we can't get coal from, I mean, for emergency purposes, whatever the power plant requirements are there, based on the requirements of power plant, you need to store coal in your coal storage bunk. Okay, right. Depending on the requirement, I mean, where the coal mines, where they are, and where the thermal power plant is there, based on it, they will try to store the storage. They will try to store the coal for some 1 or 2 months or 3 months reserve will be stored, so that there won't be any scarcity of coal. Why? Because if there is a scarcity of coal, or if suddenly, if there is some problem, I mean, like transport problem, or if there is some problem related to uh, rela- uh, related to, I mean, bringing of coal, or if there is any problem in coal mines, whatever it might be, it will affect the working of thermal power plant, or the generation of the thermal power plant will be stopped. If the generation of the thermal power plant will be stopped, obviously there won't be any power, and 70% of the thermal power plants in a I mean 70% of the electricity is generated in our country, it is based on thermal power plants. So definitely you need to have coal in reserve quantity, so that there won't be any shortage for producing electricity, or there won't be any any breakdown for production of electricity. Right, coming to the storage of coal, there will be many coal storage bunks in a thermal power plant. Means a thermal power plant, usually it will be of huge size, it won't be of a small size, because I mean you need to from the equipment of the power plant, you need to even have a separate place, or you need to have a large area for storage of coal. So definitely coal storage also matters. Right. Next is coal handling plant. Right. After that, I mean, what they do is directly coal will not be sent into the boiler. Right. Coal, I mean, whatever the coal which you get, the semi-bituminous coal, whichever you export it from coal mines, or whichever you bring it from coal mines, that coal should be pulverized. Means the coal, whatever is brought from the coal mines, I mean the coal which is kept in storage plants. After I mean it should be sent to coal handling plants. Means in this, coal will be crushed into very small or fine pieces, which is called as, this method or this process is called as pulverization of coal. Right. So you need to do pulverization of coal, and then after pulverization of coal, this coal should be sent to the boiler. Okay, in the boiler furnace. Okay, this coal will help in converting water into steam. Right. Next is whenever this uh, and right, from boiler you are having two rectangular shaped boxes on which it is written ash handling and ash storage plant. Again, right after, as you are passing, or as you are sending the coal into boiler, from coal handling plant, coal is being sent to the boiler. In boiler, a combustion takes place. Okay, I mean combustion means in presence of oxygen, you'll try to burn, and you'll try to convert water into steam. Right, as you are giving the coal to the boiler, what happens is, as the temperature of the water increases and water gets changed into steam. Right, this pulverized coal, I mean whatever the capacity of coal it is there, that much amount of heat will be released from the coal. After the coal has done its useful work, this coal the pulverized coal will turn into ashes. This ashes will be collected at the bottom of the furnace. If suppose this is the furnace, this ash, by using ashtrays, you will collect at the bottom of the boiler. You will ash connect ashes. These ashes are sent to the ash handling plant. Again, in this ash handling plant, again, if suppose, I mean, they'll try to properly segregate ash, and they'll try to store ash. Against for storage of ash also, separate land is required. Okay, this ash, they will decide whether it should be dumped, or it should be sent to any industry, any factories or industries, so that from that any ash bricks, or from that any material will be made. Right. Next is above boiler. Again, there are two rectangular boxes. On one it is written air preheater. On another it is written economizer. Right. On the air preheater, again it is written id fan, which is induced draught fan. Okay, and on the right side of air preheater, it is written fd fan, which is forced draught fan. Right. And next is, at the end of induced draught fan, exhaust gases will be released into the atmosphere. Right. This exhaust gases, right, as in boiler, combustion takes place. Combustion takes place means heating of coal will be done. Okay, heating of water will be done by using coal. I mean, combustion means burning anything in presence of oxygen. This burning is done with the help of coal. Right. While coal is getting, while we are allowing the coal to burn, we need to supply some oxygen, which you obtain it from induced draught fan. This induced draught fan from outside atmosphere or from outside air, they try to take some oxygen, and this oxygen will be supplied to the boiler so that combustion will take place in a proper manner, right? Next is right next is next is the down one. Okay, the down one, down to the down of boiler, what all the parts are there I am telling. Okay, it is raw water, right? What is raw water means? What I mean, water which is taken from river or nearby, whatever the lake or pond, whatever is there, from there we will try to take water. Why water is required or why water is sufficient means, why water is necessary means, because we as we are boil in this, in thermal power plant, whatever the main procedure we are doing is we are boiling water. Okay, I mean, in order to produce heat energy, we are trying to boil water by using coal. So we need to have coal, we need to have water. I have explained in detail about coal. I mean, what all should be done, what all procedures should be done for coal before sending it to boiler. Second is, we will discuss about water. This raw water will be taken from the river or lake or pond. It will be given to make up water treatment. Means in water some dissolved gases all will be there, even some dirt, mud, whatever will be there. First, whatever the sand or mud particles, whatever it will be there, it will be removed out. That is, makeup water treatment will be done, and after that, this makeup water will be sent to deaerator. Deaerator means dissolved gases will be removed from this deaerator. Okay, right. And next there are LP feed water heaters and HP feed water heaters. Means LP means low pressure feed water heaters, and there are high pressure feed water heaters. I'll explain this also while explaining air preheater, economizer. I'll explain this also. Right, coming to the right side at the bottom. Okay, from the end of the condenser. Okay, exhaust stream. Right, from the end of the condenser, it is getting connected. Sorry, from the end of the turbine, it is getting connected to the condenser. Right, I told that the steam from the main valve, the steam will be sent to the turbine. This the steam whichever will be forced, will be allowed to pass on the blades of the turbine. Okay, some steam will get exhausted. This exhausted steam will be passed to the condenser. Okay, after passing this steam to the condenser, what happens is, in condenser, the temperature of the steam will be reduced. Okay, and the temperature of the steam will be reduced, and next what happens is, how the temperature of the steam will be reduced in condenser means, we will allow cool water to pass through the, to pass through this steam tubes. We will allow the cool water to pass through this, right? After cool water will be passed through this, and the temperature of the steam will be reduced. Whenever the temperature of the steam reduces, it will turn into water, and this water, all obviously it will be a pure water. Why? Because this water, the whole treatment is done, the whole treatment, the initial whatever the water treatment should be done, that is done for this water. Why? Because it is coming out from the, this is the form of exhaust steam which is coming out from the turbine. Means it is almost, it is passed through makeup water tank and deaerator. So it is pure water type. So this water, again they won't pass it into river or anything. This water will again be back circulated into the boiler tank. Right. Next is, whatever the, in condensers, whatever the cool water which you are allowing to pass through the exhaust steam, what happens is, the temperature of this cooling water, the this water also increases. So this water again, in order to reduce this temperature, again it will be passed to the cooling tower. As this water will be passed to the cooling tower, what is this cooling tower is, again different sets of arrangement of tubes will be there. Again the water will be passed like passed, even artificial cooling towers also will be there. I mean they will allow, I mean natural fans, or the artificial fans, artificially fans will be induced, and they will reduce the temperature of the cooling water, cooling water, right, which will be passed in the which will be passed around the exhaust stream in condenser, in condenser, um, right. Again at right side you are having circulating, again in right, and again to the left side of the cooling tower you are having circulating water pump. I mean the water should be circulated in the condenser compartment, right? So for that again you need to have a circulating water pump, right? Again on the top right side top I have not explained, I will cover that. From the alternator what happens is you get I mean mechanical energy will be converted into electrical energy. By using an alternator you convert mechanical energy into electrical energy. Okay, so right, again this electrical energy you don't, I mean we can't expect that whatever the electrical energy whichever is generated, it will I mean in the nearby areas if you want to supply you can supply it. But I mean if suppose thermal power plant is very far away, or usually thermal power plants are constructed outskirts. Usually, thermal power plants are constructed at outskirts only. So what happens is, whatever the electrical energy which is generated, definitely it needs to be transmitted. What they do is, again, this electrical energy, I mean, again, by using a step-up transformer, whatever the electrical energy is generated by the alternator, based on the capacity of the thermal power plant, again, this the voltage will be stepped up, and after stepping up again you are having an isolator and circuit breaker. Again after that again isolator, and again it is given to bus bars, and again it is transmitted to long away distances, right? After receiving there again they will step down. Okay, and again it will be given to industrial purposes, or it will be given to domestic applications, right? Next, right. In this again at superheater, from superheater to economizer, again you are having a dust collector, a small circular shaped thing, right? Whatever is there, whatever the steam which you are allowing from superheater, I mean which you are after boiler the steam will be given to superheater. Okay, again from superheater the steam will be given to main valve. In superheater, in the steam, if any dust particles, or if any dust particles are there, that will be collected by this dust collector, right? Next I will explain about air preheater and economizer also. What is air preheater means, this air preheater, uh, no, sorry, I'll explain about air preheater and economizer later in the slides only. Here, I mean FD fan and ID fan, I will tell once again, and I'll explain air preheater and economizer also. Coming to line diagram of thermal power station. So this is the line diagram. Okay, again you are having coal supply, you are having a tower like thing where you are trying to supply the coal. Again, what is a conveyor belt is, conveyor belt is the passage or the path for for passage of coal supply to boiler. And again in boiler, in downside you are having some golden color, means you are doing combustion, or you are performing the combustion, and on that some tubes are present. In these tubes, what you do is you allow water to pass. Okay, as you are allowing water to pass, what happens is, as you are performing combustion in boiler and water is being passed from tubes in the boiler, the temperature of the water increases, or water will get converted into steam. Okay, by using a boiler, and after that the steam will be given to the steam will be given to turbine. And what this turbine does is, and the blades of the turbine will rotate based on the pressure of the steam which is applied. Okay, the blades of the as the blades of the turbine rotate, what happens is mechanical energy will, you will get mechanical energy as output. This mechanical energy will be given to generator. This generator will convert mechanical energy into electrical energy. And what happens is, electrical energy means you are getting three-phase AC as output. That is given to switchyard or some step up transformer. Right, again you are having at the end of the turbine, you are having a small component, okay, which is in blue color here, which is called as condenser. What this condenser does is, at the end of the turbine, the steam is this exhausted steam is given to condenser. And from river or reservoir, at the at down part of the slide, at the left corner to the downside of the slide, we are having river or reservoir. From reservoir, I mean, you are adopting natural cooling technique here. Okay, even you have artificial cooling techniques also. I mean, the places or the areas where natural cooling technique is not available, there what they do is, they will adopt, or they will install a cooling tower. In this cooling tower, naturally they'll try to cool the water, or artificially they'll try to cool the water which is coming out from the condenser. Right, as this river or reservoir which is there, this is natural type of condensation which we are doing. Means from river or reservoir we are taking cool water. Okay, this cool water we are trying to pass through the condenser. Okay, in condenser we are having exhausted steam which is coming from the turbine. So this exhausted steam, obviously it will be at very high temperature. As the cooling water is passed through the condenser, what happens is, right now, from the water from the river or reservoir, it is passed into the condenser. In this condenser, you are having the exhaust stream from the turbine. This condenser will cool the exhaust. Sorry, this condenser will bring down the temperature of the exhaust steam with the help of the water which is being taken from the river or reservoir. It will decrease the temperature of this exhaust stream, and this exhaust stream will convert into water. And this water, it will not require any water treatment. Okay, as this is a pure water, it can directly be given to the boiler. Right, and next to this, whatever the water which is the water which is allowed to pass through the condenser for cooling purpose, the that water temperature also increases. That temperature again, water, the increased temperature of water, I mean, the water with increased temperature will be sent back to the river or reservoir. Again fresh water will be taken from river or reservoir. This is done in natural condensing. This is done in thermal power plant with natural condensation process. If you want artificial cooling, or if you want artificial condensation, what happens is, whatever the temperature which will increase in whatever the temperature which will increase in the water, which will increase, I mean, whatever the water which we pass through the condenser, the increased temperature of the water will be passed through, will be passed to the cooling towers artificially. I mean by some forced fans, or by natural air. by natural method or by forced flow of air. The temperature of this water the temperature of the water which is used in condenser, that temperature will be reduced and again it will be supplied back to the condenser. Okay, this is about the line diagram of the thermal power plant. Right, in the last slide I have not explained about air preheater, superheater, okay, forced draught fan and induced draught fan. Right, I will deal with that topics, and so that we will have a clear cut clarity on uh, line diagram of thermal power plant. Right. I have not covered air preheater, economizer, forced draught fan and induced draught fan. See what is induced draught fan is. First I'll start with induced draught fan. Induced draught fan, it is nearer to chimney. Okay, is this chimney will expel gases out of the thermal power plant. Whatever the gases which will come out in thermal power plant, that will be expelled through the chimney. Right, as this will be expelled through the chimney, I mean, at the end, or this induced draught fan will be attached between this chimney and dust collector. Okay, this induced draught fan will create a negative pressure. Means it will try to remove the flue gases, dust, whatever the dust or whatever the flue gases are there. It will try to give it to the chimney, or it will supply it to the chimney, so that chimney will remove it from this thermal power plant. Right, this is the work of induced draught fan. Right, coming to forced draught fan. Forced draught fan, what it is in boiler, for combustion you need to have some air. Okay, means you need to have some oxygen directly. As you can't supply oxygen, what we do is we supply air, or in presence of air we try to do combustion. Combustion means burning of something. So as we try to do combustion in presence of oxygen, we supply air. This air will be supplied. This air will be. I mean, in order to supply this air to the boiler, we require a forced draught fan, which is known as FD fan. Okay, this FD fan. I mean, this forced draught fan takes air from the atmosphere. Means it will create a positive pressure. Your induced draught fan will create a negative pressure. Means whatever the waste or the flue gases, whatever are there, that will be expelled to the chimney, or that will be supplied to the chimney with the help of induced draught fan. Forced draught fan is, it will take fresh air from the atmosphere. This air will be given to the boiler. Why? Because in order to have combustion, as the temperature in the boiler will be very high, what it does is it will pass this air which is taken from the atmosphere through air preheater. Right, this, after passing it through air preheater, that air only it will give it to the boiler. I mean, instead of directly giving the atmosphere air to the boiler, it will pass through the air preheater and it will give it to the boiler. What air preheater does is, air preheater will take the energy from will take some heat energy from the flue gases. Right, what air preheater does is, it increases the temperature of the air which is getting passed through it. Right, from where it gets from where it gets this heat energy. Means this heat energy, this air preheater means, you will allow flue gases, I mean from the boiler, whatever the flue gases are coming out, if combustion is taking place, definitely many amount of gases, even dust will come out, I mean will get released. So as dust will come out, so you need to have a dust collector. This flue gases also are dangerous. Okay, this flue gases also will increase the pressure in the boiler. So we need to expel, or we need to remove these flue gases outside the boiler. So what we should do? So these flue gases should be given to the chimney. So instead of giving these flue gases directly from boiler to chimney, what we do is we try to pass these flue gases from boiler through through superheater, economizer, and air preheater. As we are passing it through these three components, what these three components, I mean, this flue gases, the temperature of the flue gases, I mean, the temperature of the flue gases or the heat energy from the flue gases will be transferred to your superheater, economizer, air preheater. Okay, so your air preheater will take some heat energy from the flue gases, and it will give this heat energy to the air which is getting air which is supplied to the boiler. Next is coming to the economizer. What economizer does is, again economizer takes some heat from the flue gases. Okay, right. Here you observe, from raw water you are giving it to makeup water treatment. From makeup water treatment you are giving it to makeup water tank. From makeup water tank it is you are giving to deaerator, or I mean, from this you are giving it to HP feed water heaters, right? High pressure feed water. You are having two types of water heaters: LP feed water heaters and HP feed water heaters. From HP feed waters, what you do, I mean, before, I mean, whatever the water which is entering into the boiler, what you do is, from the condenser, whatever the water right, from the condenser, whatever the water you are getting, I mean, after melting the, sorry, after liquidifying the exhausted steam. Okay, this water will be passed through LP feed water heaters, and again it will be through deaerator, it will be passed to HP feed water heaters. This water, I told that it will be sent to the boiler. Okay, after passing through LP feed water heater, HP feed water heater, this water will be passed through economizer, and it will be given to the boiler. Right, as it is getting passed through economizer, this economizer, by using with the help of flue gases, this economizer will increase the temperature of this feed water again before supplying it to the boiler. Next, again, whatever this superheater is there, this superheater also increases the heat of the steam which we are getting from the boiler. This heat energy is again supplied by the flue gases. Right. Right. With this, the line diagram of the thermal power plant, the explanation of the line diagram of thermal power station gets completed. In the next class, I will deal about each part, and I will read whatever the data is given for each part in this PPT. And after that we will discuss whatever the parts are left over, or whatever some data which is left over about thermal power plants, I'll deal in the next class. So with this, I will try to stop the class. Thank you.